In nature, substances are classified in three ways. First is insulator. Second is conductor. And third is semiconductor. Now, insulators are those substances whose not easily allows the flow of electricity. Reason behind this is, if we consider the atomic structure of the insulator, its outermost orbit is completely filled. Its outermost orbit electrons are tightly bound to the nucleus, therefore it is not detached easily if electric potential is applied. Therefore, the insulator R does not allow to flow electricity. Now, if we consider conductors, now in conductors, for example, aluminum, copper, gold, platinum, cobalt, nickel, in such metals, its outermost orbit is incompletely filled. Outermost orbit electrons are loosely bound to the nucleus, therefore it is easily detached from the orbit and takes part in conduction. Therefore, in conductor, if we apply electric potential, electric current is easily flow. This offers very low resistance to current. Therefore, this is called conductors. And semiconductor are those materials whose electrical conductivity or electrical resistivity lies between that of insulator and semiconductor. In semiconductor, there is bonds, and if we apply electric field, bonds are broken and we get the electric current. Now, in terms of energy band diagram, insulator have, for example, conduction band and there is valency band. There is large gap called forbidden gap in case of insulator. Therefore, if we apply electric field, it is not possible to cross these or diffuse this band, or it is not possible to electrons goes from valence band to conduction band to take part in the electric conduction due to large forbidden gap. Now, in case of conductors, conduction band and valence band overlap each other. Therefore, there is large number of free electrons available for in conduction band, and therefore it is possible to flow of electricity. There is overlap between conduction band and valence band. In case of semiconductor, forbidden gap is so small that we can apply it is about 1 electron volt. If we apply electricity, then current electrons goes from valence band to conduction band easily, and therefore we get some hot electric current. Now, next point is very important law we are considering here, that the invention of this law is George Simon Ohms, and it is useful in network analysis. It is statement of this law is in this way. At cost statement of Ohm's law, at constant temperature, current flowing through conductor, is directly proportional to applied voltage. Now, Ohm's law statement of Ohm's law is in this way: at constant temperature, current flowing through conductor is directly proportional to applied voltage. That is mathematically I is directly proportional to V. Now we have V equal to Ri, where R is the proportionality constant and it is called resistance. Now we replace the V by Y, R by M and I by X. Then we get equation of straight line y equal to mx, and it is nothing but straight line passing through origin. Now here we indicate that this equation indicates that there is a very linear relation between voltage and current. And in other words, as voltage increases, current increases. This is statement of the Ohm's law. Now we have, what is power? Power is nothing but product of voltage into current. Power is, in DC circuit, power is voltage into current, and unit of power is watts. Now another formula for power we can be easily derived from expression. Suppose in place of V I am writing I into R into I equal to this becomes I square R watt. This is another formula for power. Now next formula for power is, in place of I am writing V by I. This becomes V square divided by V by R. This becomes V square divided by R. This is another formula for power. Now this is about Ohm's law and different formulas about power. Now we consider one example. A electric motor gives an output power of electric motor gives an output power of 20 kilowatt and operates with efficiency of 80%. Supply input voltage to motor is 200 volt. What is constant current flowing through motor? And they ask you to find out what is constant current flowing through motor. Now from this example, they ask you to calculate current flowing through motor. Now the given data is the given output power P naught equal to 20 kilowatt. They also given efficiency, percentage efficiency. Now calculate it in fraction. Efficiency is 0.8, and they also given output supply voltage V equal to 200 volt. Now they ask you to calculate current flowing through motor. Now from this problem here we can calculate easily output current. Now remember that here relation of efficiency and power is in this way. The efficiency eta equal to 0.8 equal to output power divided by input power. Now from this expression, with the given output power, we can easily calculate the input power. PIN becomes output power is the given 20 kilowatt. Now convert into watt, 20,000 watt divided by 0.8, and here we get input power PIN equal to about 25,000 kilowatt. So 25,000 watts. Now next they ask to calculate current flowing through the motor, and a relation of power and voltage and current is given in this way. Power is nothing but input voltage VIN into input current IIM. Now input voltage, they supply voltage, they given 200 volt. We are already calculated for input power 25,000 watt, and here our IM is to calculate input current I. Now here from this expression we can easily calculate the input current. It is 25,000 divided by 200, and it current turns out to be 125 amperes. Now this is simple example we are considering, which depends upon Ohm's law, and we are consider their efficiency and relation of the output power, input power, etc. Now, this is example of Ohm's law. Now we have considered here series connection of resistances, series circuit, series circuits. Now what is definition of series circuit? Now series circuits are those circuits if we are connected resistances one after another, then it is, this type of connection is called series circuit. We are connected R1, R2, R3 one after another. We give the supply voltage V to this network, and due to this supply V voltage, current I flow through this network. Now what is characteristic or properties of series circuit? Now here properties of series circuit is first property is same current flows through all resistances. This is very important property of series circuit. In resistance network current is I, and your current flowing through resistance R1 is also I, current flowing through resistance R2 is also I, current flowing through resistance R3 also I. Means same current flowing through all resistances. Their supply voltage V is sum of voltage drops across each resistance. Supply voltage is sum of voltage drops across each resistance. Means V1 equal to V2 plus V3, V1 plus V2 plus V3. Where V1 is drop across R1, V2 is the drop across voltage drop across R2, V3 is voltage drop R3. Now here voltage, supply voltage is nothing but current I, circuit current I into total resistance, P into R total equal to I V1. V1 is nothing but I into R1, product according to Ohm's law, I into R2, and V3 is I into R3. From this expression, we can achieve new relation as the total circuit resistance RT becomes R1 plus R2 plus R3. Now in series circuits, equivalent resistors or total resistance is sum of all series resistances connected in series. This is second or third property of series circuits. And what is about of power? Power is, remember that power, we can calculating power. Now we have a relation like this, RT equal to R1 plus R2 plus R3. Now we are multiplying power is I square into RT. Now from this relation, RT equal to R1 plus R2 plus R3. Now we are multiplying on both sides by I square. Now this becomes I square RT equal to I square R1 plus I square R2 plus I square R3. Now this is I square R3 is total power consumed in circuit, which is indicated by letter P. I square R1 is power is consumed or dissipated at resistance R1. This is P1, and I square R2 is power dissipated in resistance R2, it is P2, and I square R3 is power dissipated in resistance R3, this is P3. Means power is additive, means total power consumed at each resistance equal to sum of powers consumed at each resistance. Now we are considering a very simple example to understand better series circuit. Now here, calculate the voltage across. Calculate. As the given circuit is like this. They given three resistances connected in series. An example number 2 we are considering here. Here resistance R1. Voltage drop across it is V1. Resistance R2. Voltage drop across R2 is V2. Resistance R3 and voltage drop across R3 is V3. And here the ohmic values they are given is 2 ohm, R2 is 3 ohm, R3 is 8 ohm. And they are given is the given circuit current equal to 1.5 ampere. This is circuit current and equal to I equal to 1.5 ampere. Now they asked to calculate supply voltage. Calculate V. Calculate V. Now how to calculate? Here, remember that for voltage P equal to your relation is P1 plus P2 plus P3. Drop across each resistance. Now how to calculate V1? Remember that P is nothing, V1 is nothing but I into R1. Circuit current is 1.5 ampere. R1 is given 2 ohm. Plus similarly, P2 is your IR2, I is 1.5 ampere into resistance R2 is 3 ohm plus IR3 1.5 into R3 is your 8 ohm. Now you simplify this expression, we have get 3 plus 4.5 plus 10 over. And after simplification, supply voltage we are easily calculating here. It is 19.5 volt. Now, here one more example. Considering in series circuit. They ask you to calculate find circuit current I, find circuit current I, then P equal to 100 volt. Network is given in this way. Series network of course. Then R1 ohmic value 40 ohm. R2 ohmic value 50 ohm, and here R3 having ohmic value 70 ohm. We are considering or simplifying the series network. They give a supply voltage about 100 volts, and they ask you to calculate circuit current. Now remember that how to calculate circuit current. Circuit current is, remember that I equal to V divided by R equivalent or R total. Your circuit voltage is 100 volt divided by RP. Now RP is nothing but it is R1 plus R2 plus R3. And here after simplification we get a relation like this. R 100 divided by 40 plus 50 plus 70, and this turns out to be I equal to 100 divided by 1 upon 60, 160, and it is turned out to be 0.625 ampere. Now this is some simple problem of